All right, so here is the CH111 types of reactions 1. So in this part, if you go to your lab report part, in your data sheet, for each reaction, you're going to write down the observation in the middle. So those observations will be based on color change, any precipitate or PPT formed, something insoluble, which means, or is there any gas bubbles formed, or if there's any temperature change. Of course, if there's any temperature change, I'll let you know. All right, so that's basically what you should write down in the observations part. Then when you want to answer the other questions, you needed to first read the description of the reaction. It will show you what would be the reactants and what would be the products. So you're going to write the equation of the formulas of those chemicals. Okay, and also you needed to balance the equation, follow the guidance in the lecture. And then you needed to, based on the balanced equation, decide what type of this reaction is. So we learning 5 different types. Is combination, decomposition, single displacement, double displacement, or combustion reactions. So you need to make a decision and put there. So that's how you answer the question. Right now I'm going to run each reaction, so you're going to observe it clearly and closely, okay? And then write down the observation. So now, reaction 1. This one is already done, so I'm going to show you the result, like what would be the color or appearance of the reactants, what would be the color and appearance of the products. So this is a copper powder. You're going to see it's powderish, okay, and what's the color? And then we have the sulfur. You can take a look at inside. It's very obvious color inside, and it's also powder. Okay. Then we mix them, add the catalyst copper 2 sulfate, and it's already heated. Okay, so you're gonna see the observation now. You can see, can compare to the original reactant's color, and now what's the color? Okay, all right, so that's the reaction 1. For this part, when you write the chemical equation, make sure don't put the catalyst into the chemical equation. And also, water is the medium dissolving the material in, so water shouldn't be in the equation as well. Now let's move to reaction 2. We need to add a few pieces of magnesium to a test tube with 1/8 filled with 6 molar hydrochloric acid. So hydrochloric acid already in the test tube. So I'm going to put several pieces of magnesium into the acid. Okay, 1 piece will be big enough. Ooh. So the reaction is kind of fast. Write down the observation. And also let's fill it's getting hot. The test tube is getting hot. Okay. Notice, do you still see the metal, the shiny metal inside the solution? It's gone. Okay, so write down the observation. So this is the reaction 2. Okay, let's move to reaction 3. We need to pour 10 milliliter of tin 2 chloride into a 100 milliliter beaker. Okay, 10 milliliter tin 2 chloride. Okay, about 10. We don't need the exact amount. Just observe the change. 5 milliliter of hydrochloric acid. So we going to add hydrochloric acid. You're going to observe the change. Okay. And 2-3 pieces of zinc. So 1 big piece will be enough. You're going to see something happening here. Can you see that? Maybe we can zoom in a little bit. If I shake, you can see more obvious. There are 2 reactions happening here. Okay. So in the procedure, they describe each reaction. What would be the reactants? What would be the products? So make sure you write 2 chemical equations here. Okay. Now, seems like the bubbles down, right? See that? Originally, we saw a lot of bubbles on the surface. Now, the surface is no longer shining. Let's get rid of the liquid. Let's get the solid piece out and observe the surface of the zinc. Put a paper towel. Okay. Now, on the paper towel, you can take a close look at the surface. Notice the color, the appearance, compared to the original shining zinc metal. You can see that, the difference. Okay, all right. Oh, in the wrong one. Okay, so that's reaction 3. Move to reaction 4. We're going to add silver nitrate solution and test tube about 1/8 filled. So it's already here. This is silver nitrate in there. Then I'm going to add a sodium chloride solutions to the same test tube, and you're going to see the observation. Okay. So that's reaction 4. Okay, I think we can continue. Now, let's do reaction 5. We need a 10 milliliter of ammonium thiocyanate. Okay, we need 10 milliliter in a test in a beaker. Take that away. Add about 10 milliliter of the iron 3 nitrate. See the difference? Okay, so that's the reaction. All right. Now move to reaction 6. We need about 10 milliliter of the 3% hydrogen peroxide solution in a 100 milliliter beaker. So I'm going to pour about 10 milliliter this time again. Okay. Then mixed with sodium iodide. So now you can see that nothing happened here, just hydrogen peroxide. But if I add sodium iodide, which is a catalyst, again, do not put this material in the chemical equation. It's just a catalyst. Your starting material, just this one. Okay. But when you add about 1 milliliter, I think the test tube is, well, the color is, the yellow color is coming from the iodide. But now you notice something happening here, right on the observation. Okay, all right. That's for reaction 6. Now move to reaction 7. Add sodium iodide solution to a test tube until it's 1/8 filled, which is here. I've already added the sodium iodide in there. Okay, now I'm going to add lead 2 nitrate into the solution, okay, until it's 1/4 filled. So about the same amount. Ooh. This is very dramatic change. Okay, so notice the color and also the appearance. Is soluble or not soluble? Okay, all right. So that's our reaction 7. Now reaction 8, we need hydrochloric acid about 1/8 filled. So it's already in the test tube. Okay, I'm going to add 1 to 2 pieces of calcium carbonate to the test tube. So you're going to see the change. Okay. Just a little bit. So the reaction is really quick. Maybe the reaction is too fast. We captured it, right? No, too quick. Let's do it again. It's too quick, so I'm going to put some acid there first. Maybe we can zoom it in more. And notice the quick change. I think this time if you capture the quick change. Okay. All right. So, reaction 9. We need to add a sodium sulfate solution to a test tube until it's 1/8 filled. So this will be that one. Okay, it's already in there. A barium chloride solution to the same test tube until it's 1/4 filled. So I'm going to add in there. So you can see the change. And right on the observation. Okay. All right. Now move to reaction 10. We need 10 milliliter of iron 3 nitrate, which is already in here. We need to add a 10 milliliter of the sodium hydroxide into it. Okay. Observe the change. Okay, so that's reaction 10. Reaction 11, we need to add a sodium hydroxide solution to a test tube until it's 1/8 filled. So already in the test tube. We need to add a hydrochloric acid to the same test tube. And this one we need to fill the temperature change. So I'm going to fill that. I'm going to let you know. But first, let's see if anything visible change here. Looks like nothing, but let me fill that. Oh, it's really hot here. Okay, so the test tube tend to hot. Okay, warmed up. All right, so that's the reaction 11. Of our reaction 12, we need to burn something. So this time we're going to pull a little bit methanol into a evaporation dish. Just a little bit. Okay. Then we needed to ignite it. Okay. The flame is very, very light color. I don't know if you can see that, or maybe against my glove's color. Okay, I can feel the heat. And I can see from here sometimes a little bit like a wind, push the flame a little bit over against the bench, so it's a little blue, very, very light blue, almost transparent. And it's still burning, I can feel the heat. Okay, when it's done, when all the methanol be burned completely out. Okay, sometimes you can see a little bit yellowish color there. Okay, so it's almost done, and then nothing left in there. It's all burned out. Okay, so that's that reaction, and then that's the end of type of reaction 1.